Okay, see a problem in buffer capacity. So it is also a very important model. Okay, see, first we explain the problem. So a buffer solution of pH is 4. So pH value is given as 4 is to be prepared using acetic acid, weak acid, and it's a salt with a strong base. Means it indicates it is an acidic buffer. So what we have to find that how much amount of sodium acetate to be used, nothing but to be added to 1 liter of m by 10 means that is 1 by 10 molarity of acetic acid. Means here acid concentration is given, we have to find how much amount of sodium acetate to be added. Okay, so here it's very important. So it is given an acidic buffer. So normally what is the general formula for acidic buffer? pH equals pKa plus log salt concentration by acid concentration. So actually we can use this formula directly, but in the calculation the logarithm value may make some difficult. Okay, so logarithm lo unnappudu manam salt find out cheyadam not an easy. సో అది లాగర్థం కాకుండా నార్మల్ దాంట్లో క్యాలిక్యులేట్ చేయొచ్చు అంటే ఎస్ వీ హ్యావ్ ఏ అనదర్ ఫెసిలిటీ జస్ట్ this equation can be written as by expanding this so c minus log h plus so ka means so pk means minus log ka plus log of salt concentration by acid concentration. So here in all in 3 terms logarithm is there. So how to remove the logarithm term, how to make it a normal thing means just using antilog. First we multiply this total equation with the minus, then what happens? So the log h plus becomes log ka minus of log salt by acid. Okay, next. So as we are doing the first time this derivation, so that's why we are doing the total derivation. From next problems, this type of problems, so we can take the direct formula of buffer solutions without logarithms. So here again I am writing this log of h plus equal to log k, make it plus. Plus means it becomes a log of acid concentration by log of salt concentration. Okay, now use the antilog. Antilog means just removal of a logarithm. So all are having logarithms, we can remove the logarithm in all terms, nothing but it is known as antilogarithm. So h plus equals, now it becomes after removal of logarithm, so it becomes k into acid concentration by salt concentration. We know in logarithm log, so log a plus b means nothing but log a into b. Okay, this is log a into b. So after removal of logarithm it becomes ka into acid by salt concentration. So in the problem already it is given h plus, not exactly it is given, so but we know that pH says it is equation 1, so pH is given as 4, so it implies minus log h plus is given 4, so therefore h plus equal, we can write, we know the method 10 power minus 4. So what is acid concentration? So acid concentration is given, that is 1 liter to 1 by m. Its concentration is 1 liter and 1 by m it is given. Then in terms of molarity we can say 0.1 m. 1 by 10 is given, just we write it as 0.1 m. We know the Ka value also. So what is the Ka is given directly 2 into 10 power minus 5. We have to find the salt concentration. Here what is the salt? CH3CONA. So this is acid means nothing but CH3COOH. We have to find the salt. CH3CONA concentration. Okay, so substitute all them in equation 1. 1 implies H plus equal how much? 10 power minus 4 equal K. Acid 0.1. We have to find the salt. Salt means nothing but sodium acetate. So 10 power. So already it is nothing but 1 liter, so we can say 0.02 moles. 0.02 moles of sodium acetate to be added to the 0.1 m acetic acid to make 1 liter buffer solution which is having pH equal 4. So in the last class we discuss system problems ఏంటంటే extra compound addition, extra acid, ఆ బఫర్ సొల్యూషన్లో లేని యాసిడ్ ఆ బఫర్ సొల్యూషన్లో లేని బేస్ యాడ్ చేసారు అక్కడ. సో కాబట్టి దట్ మెథడ్ ఈజ్ సూటబుల్. ఇక్కడ అదే దాంట్లో ఉన్న అదే బఫర్ సొల్యూషన్లో ఉన్న కాంపౌండ్ ఫైండ్ అవుట్ చేయాలి కాబట్టి వీ కెన్ యూజ్ this formula. From next onwards we can take it as a direct formula. Okay, actually from this formula only we obtained this type of general buffer solution formula. Okay, okay, see the next one. So calculate the pH of a buffer formed by mixing 0.15 mole of ammonium hydroxide, it is a weak base, and 0.25 mole of ammonium chloride. So this is the salt formed by this weak base with a strong acid, means it is a weak basic buffer. So you can say it is a basic buffer. So for basic buffer we have the formula POH equals pKb plus log salt concentration by weak base concentration. So we have to calculate the pH. For bases always we calculate POH. So what is pKb? So here it is given Kb for ammonium hydroxide is given. We have to find pKb. pKb means minus log Kb. That is 2 into 10 power minus 5 plus log of. So what is the salt? So which is the salt, which is the base? We have to identify. So ammonium hydroxide is the base, ammonium chloride is a salt. So actually both are present in 1000 ml. So both are present in 1000 ml mixture. So no need to consider the value. Salt concentration 0.25 moles in 1 liter. Again base concentration 0.15 mole in 1 liter. Okay. So this becomes minus log 2 so this becomes log 5 minus log 3. So on further calculation, log 2 value, so 0.3010, this minus 5 comes to the front, it becomes 5 log 10. So log 5 value is 0.6990 minus log 3. So we have to, it is compulsory to remember the logarithm values from 1 to 10. Okay, log 3 is 0.4771. So on overall calculation, here we get the p over h 4.92 and ph is equal to, we know, so this is the pH of the given basic buffer. So the calculate the pH of 0.1 m 50 ml ammonia solution when treated with the 25 milliliter 0.1 m 1 m HCl. So here pKb means we know it is for always weak base. So ammonia is a weak base. Its pKb is given. So at first we see what reaction takes place between the NH3 and HCl. So already we done this type of problem. So there is a formation of ammonium chloride. So it's a base acid reaction, formation of ammonium chloride salt. As there is no OH by hydroxyl ions in ammonia, there is no formation of water. So according to the reaction, this is 1 mole of ammonia reacts with 1 mole of HCl, forming a 1 mole of ammonium chloride. According to the equation, all are in 1:1 ratio. Okay, so but it is given how much? 0.150 milliliter. So 0.1 into 50 milliliter, so that is a 5 millimoles. So it is given in terms of molarity is given, volume is also given. So volume also given. That's why we do the problem in terms of millimoles. Okay, so means it is given 5 millimoles of ammonia. Next, what about HCl? HCl is a 25 milliliter 0.1 m. 25 into 0.1, that is 2.5 millimoles. Means 2.5 millimoles of HCl is given. So compare these two. So actually they are in 1:1 ratio. This is 5 millimoles, this is 2.5 millimoles. So here the information of two reactants given, we know that we have to follow the concept limiting reagent. So here what is the limiting reagent which is consumed totally in the reaction? Here for 5 millimoles of ammonia it required 5 millimoles of HCl because they are in 1:1 ratio. As they are 1:1 ratio, 5 millimoles is also required, 5 millimoles of HCl, but it is not given. Only 2.5 millimoles of HCl is given. So here the limiting reagent is, what is the limiting reagent? The limiting reagent is HCl because 2.5 millimoles reaction lo participate aithe, so total HCl complete అయిపోతే now there is no further reaction, mean there is no extra left. The amount left which is unreacted is 2.5 millimoles of ammonia. So here we can write main point. Here limiting reagent is HCl. So we can write a statement 2.5 millimoles of HCl totally reacts with 2.5 millimoles of ammonia. So then what about product. So how much? It is also 1:1:1 ratio. 2.5 mole reactant ఇది 2.5 mole reactant ఎంత అమోనియం క్లోరైడ్ ఫామ్ అవుతే 2.5 moles. So and 2.5 millimoles of ammonium chloride salt is formed. So now observe the final solution. So after completion of the reaction, what we observed? After completion of the reaction, there is a total consumption of HCl. Now there is a no HCl is present. Total 2.5 HCl is reacted. So how much in the 5 millimoles of ammonia, only 2.5 is reacted. Therefore now there is 2.5 millimoles of ammonia is present, and ammonium chloride is formed is also 2.5 millimoles. Okay, means we can write after the reaction. So writing of this statement is very important. This is very important one. So therefore now means after completion of the reaction, the NH3 is present. For starting 5 millimoles, the 2.5 is reacted, that is equal to 2.5 millimoles. Next, what about the salt? What about the salt? That is NH4Cl is present. So this is formed, already it is formed 2.5 millimoles. Means it is a mixture of NH3 plus HCl, NH4Cl. So it works as it is a basic buffer. It is a basic buffer solution. So as it is a basic buffer solution, and we know the concentrations, so we know the pH. So as the base we have to calculate pOH, so pKb plus log salt. What is the salt? Log salt by base concentration. So what is the pKb? pKb is given as in the problem. This 4.76 is given plus log of. Same we are getting 2.5. 2.5 it becomes log 1. We know that log 1 is 0. So log 1, we know that log 1 value is 0. So therefore pOH is equal to 4.76. So actually we need the answer for pH. Therefore pH is equal to 14 minus pOH. So it becomes 9.24. Okay, this is the pH of the final basic buffer solution. Okay, see one more problem. So actually it is a very different model. So consider a buffer solution containing 0.1 mole each acetic acid and sodium acetate. It is containing weak acid and salt. So we know that acetic acid is a weak acid, so it is given an acidic buffer. So in 1 liter solution, so 0.01 mole of sodium hydroxide, strong base, 0.01 mole of sodium hydroxide is slowly added to this buffer. So what is the calculate the average buffer capacity? So we know the buffer capacity formula. So buffer capacity formula generally with its symbol phi. So some books it is also given as beta. Okay, we can follow any of them. So already we followed this phi equal to, what is the formula for buffer capacity? The number of moles of acid or base added by change in pH, change in pH value into volume in liters. So it is the formula. So here main important, we don't know the change in pH. We know the number of moles of acid or base. The number of moles, 0.01 moles of base is, we know that. What is the volume? Volume also given 1 liter. But we have to know what is the change in pH. Means we have to find the initial pH. అంటే మనం 0.01 మోల్ NaOH యాడ్ చేయకముందు pH ఫైండ్ అవుట్ చేయాలి. యాడ్ చేసిన తర్వాత pH ఫైండ్ అవుట్ చేయాలి. అంటే 2 times we have to find the pH for this buffer solution. Then we know the change in the pH. Then substitute in equation 1. So at first it means before the addition of this, okay, means we calculate initial pH. Initial pH of buffer equal pH equals, so in the brackets it is also given pKa 4.7, okay. Log salt, what is the salt? CH3CONA. Log salt concentration by weak acid concentration. So actually in the problem itself it is given pKa. pKa was actually it is given in the problem, that is 4.7. And what is the sodium acetate? Acid, sodium acetate and weak acid both are having same 0.1, 0.1. So log 0.1 by 0.1, here we get log 1, log 1 0, we know that. So therefore pH is equal to 4.7. So this is the initial pH. This is initial pH. I am taking it as a pH initial. Just I am using a symbol I. pH initial. Next we have to find. So మనం final pH find out చేయాలి. Final pH అంటే the pH of buffer solution after adding 0.01 mole of NaOH. 0.01 mole of NaOH యాడ్ చేసిన తర్వాత మనం final బఫర్ సొల్యూషన్ pH ఫైండ్ అవుట్ చేయాలి. సో ఆల్రెడీ మనకు తెలుసు సోడియం హైడ్రాక్సైడ్ అంటే స్ట్రాంగ్ బేస్. అక్కడ స్ట్రాంగ్ బేస్ యాడ్ చేస్తే ఆటోమేటిక్గా యాసిడిక్ స్ట్రెంగ్త్ డిక్రీజెస్. అంటే ఇక్కడ weak acid concentration decreases. So sodium hydroxide, this is sodium acetate. So means the concentration of the salt increases, the concentration of the acid decreases. Okay, we have to know this statement well. So here we have to write an important point. Adding strong base to an acidic buffer, what happens? Concentration of acid base, strong base addition కాబట్టి automatically some of the salt will be, some of the acid will be neutralized. Concentration of acid decreases and concentration of salt increases. So then what will be the final pH? The final pH also increases. So final pH, we calculate the final pH. So first we see after adding so after adding 0. Just wait. After adding 0.01 moles of NaOH, so what will be the concentration of salt? Means what is the concentration of sodium acetate? We know that the salt concentration increases. Initially how much concentration was given? For the 0.1, how much it is added? 0.01, it becomes 0.11. Okay, as they are present in 1 liter carbon, direct we can say molarity. So what is the concentration of acid? We know that for acid, for acidic buffers, by adding the strong base, its acid strength, the concentration of acid decreases. Means 0.1 minus 0.1. So ఇదే model మనకి the last class we done the problem addition of HCl or addition of NaOH. So actually మనం ఆ problems లో how much amount of acid should be added, how much amount of base should be added, దాని ఎక్స్ మోల్స్ అని తీసుకున్నాం. సో ఇక్కడ ఆల్రెడీ ఆ వాల్యూ ఇచ్చింది మనకి. సో దట్ ఈస్ హియర్ వి గెట్ 0.09 m. So therefore as it is a acidic buffer, so pH equal to pKa plus salt concentration by acid concentration. So the pH equal P power Ka directly given. There is no change in the pK. So how much it is given? 4.7 plus log of. What is the acetate? 0.11 by 0.09. So already we know the log 1.22 value. So but at last we'll get 4.787. So we are taking this pH final. We are taking this pH final. Okay. Already we know the pH initial. We know the pH final. Now we are able to know the change in pH. So that is therefore change in pH. So already we know the acidic strength decreases. Acidic strength base add చేస్తే automatic acid strength decrease. Acid strength decreases and then pH value increases. So how much increase? So there is here we can say final pH minus initial pH. Okay. 4.787 minus 4. I think it is 4.7. So finally we get to 0.087. Means what is the change in the pH? 0.087. Now we are able to find the buffer capacity by substituting it in equation 1. So by substituting in equation 1, what is the phi value means? The number of moles of acid or base added, 0.01. What is the change in pH? 0.087. Next, what is the value? It is already given 1 liter. So on this overall calculation, we will get 0.1148. The buffer capacity of the solution is 0.1148. Okay.